Hi, good morning. Today, uh, we are going to explore the exciting topic from the circular motion, and the topic is centripetal force. Before we begin, let me ask you some question. How a body that is moving in a circular path, kept in a circular motion, how it is how it is happen, and uh, if you are if you see in a real world, right, there is a very sharp turn, and when a car moves in a circular path, uh, that how which where are the force that kept the car in a circular path, and you observe that the car which is moving at a very sharp turn, uh, like you see in this example, that there is a sharp turn, and when the person who is sitting inside the car he is pulled in outward direction due to its inertia, and but certainly, like where does the force comes from, and that a body moves in a circular track, like this is a circular track, and when a body moves in a circle, so what where are the force, from where the force that acts on the body. There are many examples, like if you take a bucket and fill it with water, and you uh, swirl that basket in a circular motion, the water inside it not falling down, even the bucket is upside down. Why the water is not falling from it? What's the reason? So today we'll answer what keeps subject moving in a circle. Okay, so the let's start from the circular motion. If we start from the circular motion, so first of all we discuss what is circular motion. Circular motion is that when the object moves along a circular path, this is the car, and when it is moving in a circle, you see here that even the speed is constant, but the direction of the object is changing at every point along the circular path. Like at that point, the direction is along the tangent from this direction, and here its direction is toward this side. So whenever you see that when a body or object moving in a circle, like this is a circle, and every point its direction is changing along the tangent, and if you talk about that it is moving in a circular path, and its direction is changing, and how can you explain that its direction is along the tangent? Like I give you the example, like if you hold the this is a diagram, yeah, if you take a string and tie it with some stone and moves in a circle, the stone moves in a circular path, and where does this force come from? This force comes from the by hand, yeah, by hand, and there is some tension in a string that provides the force which keeps the stone to move in a circular path. So what happens if at that point string breaks? So at that point the stone or rock move along the tangent. So its direction is changing at every point, which is seen here. Like this is a diagram that I draw here, that every point its direction is changing. So whenever there is a direction changes, so the velocity also changes and produce acceleration, and when there is acceleration there must be a force. So that force is provided and its scenario is different in every case. The scenario is different. Like if you take an example in which object moves in a circular path, two example that I explain here, but there are other examples as well. Like if we talk about the satellite that revolve around the Earth, the satellite that revolve around the Earth in a fixed orbit, where does the force come from? The force which provides the satellite that it keeps in a circular track, that force comes from the gravitational force of the Earth. Yes, absolutely. So at that point, the centripetal force provided uh, to the satellites, um, actually, uh, whenever or whatever the object that revolves or moves in a circular path, it needs a force, and that force is a centripetal force. So, centripetal force, if we talk about its meaning, centripetal. What is the meaning of centripetal? Actually, it is a center seeking force. Center seeking force is what that object revolves around the earth. It moves, the force acts on it toward the center. Like there is a car, another example of stone that is tied with a string. It revolves also around in circle, satellite revolve in the circle, and like if the moon revolve around the earth, sun revolve in another way, Milky Way galaxy. So every object which revolves in circle, there must be a force that is provided to that object which kept to move in a circular path, and that force is a centripetal force. Okay, so centripetal force is a center seeking force that causes an object to follow a circular path, and its formula is F is equal to mv square over r, where m is a mass and v square over r is the centripetal acceleration. Centripetal acceleration, where does the centripetal acceleration come from? I tell you earlier that the direction of the object is changing at every point when it is moving a circular path, so it provides acceleration, because when the direction changes, velocity is changing, the magnitude of the speed is constant, but due to the change of direction, it produces acceleration, and that acceleration is called centripetal acceleration. Okay, so move forward. uh, this is a slide in which it explain another thing, that we can give any name to in different scenario. Like centripetal force is uh, is not a fixed name of that force, like it is different in different scenario. uh, like when you take the example of the earth, that it revolves around the sun. So at that point, at that scenario, or in that example, the centripetal force come from the gravitational force. And in the same way, if we talk about the electron revolve around the nucleus, it is also the in which it is also that electron revolves around the nucleus. So that force comes from the electrostatic attraction between the nucleus and the electron. So that force between the nucleus and the electron provides the necessary centripetal force, and the electron continues to revolve around the nucleus. So we can give to any force that is directed at right angle. Yeah, it is right angle to that motion which produce circular motion. The centripetal force is a moved object. Yeah, this is I explained you earlier. Another example, another thing that we discuss here is the centrifugal force. Centrifugal force is what? Centrifugal force is not the reaction force of the centripetal force. Actually, uh, it is a fictitious force, or false or fabricated. If a person who is who take this as it is a reaction of action and reaction, like it is a reaction of centripetal force. So there is no force pulling you outward. Actually, it is due to inertia when the object moves in a circular path, and when the string that tied to the stone, and at any point Like if you're sitting in a car and when it takes a sharp turn, you pulled outward. Why? It's not a centrifugal force, actually, it is due to the inertia which keeps you to move in that direction in which the force acts. Like if you move in a straight path, so when the sharp turns act, your body moves in a straight path. Due to inertia, you fall outward. But actually, it is not a centrifugal force, it is due to inertia. So there is no centrifugal force when we discuss in centripetal force. Similarly, we go to the next. Yeah, there is uh, a question that makes your concept clear, like the force that causes an object to move in a circular path acts in which direction. Obviously, it is a centrifuging force, so the first option is correct, that is inward towards the center. Like this is example. So when the object moves in a circle, the force that acts on it toward the center. um Curved in a circle. Second option is curved in a circle. Yeah, curved in circle, but tangent. Your direction is tangent. Curved away from the circle. This is a graph you see here, that there are very little chances of all these, but the majority, the most correct option is inward towards the center. If you were to remove that force from the object would take a part that looked like. Which object? Yeah, this is a path that took like at that point when the centripetal force is removed, like the string that holds the object to move in a circle path due to the tension force. At that point, the object moves in a straight line, like it is along the tangent. So its most probable answer is C. Along the tangent, it moves. You're traveling in a passenger seat of a car. All of a sudden, the driver makes a sharp left turn. Sharp left turn. So you move opposite to the left, like right. Imagine that you are a passenger in a car which is making left turn as the car begins to take turn. Similarly, that I tell you yeah. Like when a car travels in a circle path, what force holds the car in the curve path?